For the following exercise, determine whether the relation represents a function. All right, so in order to understand this, we first have to know the definitions, right? So on the bottom, we just have to memorize these two. Very straightforward. It says a relation is simply a set of ordered pairs, x and y. So set down here means two or more, all right? So here we have a set of ordered pairs. We have one ordered pair here, two ordered pair, and three ordered pair, all right? There are two or more ordered pairs within this entire set, and therefore I could call this a relation. Now, further, in order to identify what a function is, we can look at the definition, right? A function is a set of ordered pairs x, y, meaning it's a relation, except there is this extra condition in which each x cannot have more than one y, all right? So each x cannot have more than one y. Now, if I look back to the information that I'm given, and remember the first term is always the x term and the second term is always the y term, right? So for this first one, it'd be x comma y. For the second one, it's also x comma y. And the third one, it's also x comma y. All right. So if I notice, each of the x values here are indeed different. Okay. I have an a, a b, and a c. And therefore, I cannot state that this is not a function. I know that's a little confusing because that's a double negative, right? In other words, this does represent a function because this individual x value, this individual x value, and this individual x value are different, and none of these, since neither of these are the same, okay, then they can't obviously have the same y value. So that being the case, we can definitively state, that this is indeed a function. So this does represent a function. All right. Thank you guys for tuning in. Please remember to subscribe, hit that like button, and we'll see you in the next problem. Take care.